do today, our agenda is we're going to go over the baby face lab. I'd love to see some of your babies that you made. Then we're going to take some notes and look at dihybrid crosses. So last week we did Punnett squares that were 2 squares by 2 squares. So there's 4 possible babies. Today we're going to take a look at dihybrids, which means we're looking at 2 traits at the same time. This makes things more complicated because now we're going to be doing a 4 by 4 Punnett square that has 16 possible babies inside of it. We'll start homework number 5 at the end of class. As you guys probably know, class is longer than it was before. That doesn't mean I'm going to talk longer. It means that there's more work time at the end of class. So it really, really is important that if you're not understanding something while you're doing your homework, to ask for help while we're in that 30-minute work time at the end of class. You should all be able to finish this homework in that 30 minutes that we give you. All right, we have an essential question today that we're going to try to answer. What possible gamete combinations can a parent pass on, and how do you set up and determine the offspring of a dihybrid cross? This should be a question mark here at the end of it. And hopefully after your homework and after the notes today, you'll be able to say, I can determine the possible gamete combination a parent can make looking at 2 traits instead of just 1. And I can set up and determine the possible offspring of a dihybrid cross. Okay, so it's twofold. You need to figure out what gametes the parent can make, and then you need to set up a Punnett square with them and figure out the offspring. All right, so let me, I want to get my computer back up on my Apple TV. All right, so I am looking for people who are willing to show us their babies that they made on Friday. So to do that, you just have to share your screen. Yeah, Blaze, you want to show us your baby? I see a hand raise. You can share and let's see your baby. No? Blaze, were you going to share? All right. I, in my classroom, have bags of Skittles that I am willing to dangle in front of you if you are willing to show me your baby. So anyone in my room that will put their baby up on the screen, or anyone in Mr. Monzon's room or Mr. Austin's, let's see some of these babies that you made. All right, let's go, Aiden. Okay, here we go. Blaze has got his. Oh, Blaze. He's beautiful. He's got some red hair. Is that a widow's peak or no widow's peak? No, he did not have one. He's got some nice freckles on his face. Does he have the Darwin point ears? I mean, he's beautiful. Did you name him? Let's see the name that you gave this. Cheese ball. Awesome. All right. Thank you, Blaze. Anyone else? Let's see some babies. Aiden's going to show his. Awesome. Let's see it, Aiden. All right, here we go. Oh, Aiden. Oh my goodness. So do we have some, is that dishwater blonde hair? Some green eyes. We had some freckles on the head. Are those hairy ears? Yeah. Yeah. Was this a male or a female? It's a female. And what was her name that you gave her? Isabella? Okay. Thank you, Aiden. She's lovely. She must have inherited her good looks from you.
I've got no
Anyone
words.
else? Anyone else willing to share their babies for our enjoyment this morning? Skittles. I have Skittles. Oh my goodness. Oh, she's gorgeous. She, it might be a he, I don't know. Who's sharing that? Who was that? Was you? Okay. Sweet. Anyone else? We got about a minute left to see some babies. Anyone else want to share? No?
No one in my
All
class
right.
wants to share.
Okay. Boo. Is Blaze in person right now in one of your rooms?
Yes, Blaze is here with me.
All right, awesome. At the end of class, send him down for some Skittles.
Will do.
All right. So let's take a look at your notes here. So if everybody would open up their genetics notes. So before we move on to today, I just want to remind you that it wasn't just drawing the beautiful picture of your baby. But this is my baby here that I made. It wasn't just drawing the picture for your homework. You needed to have this chart filled in at the beginning. And then you had to answer these questions on the last page. So just remember 5 and 6, you didn't have to do. So you should have crossed those out, but the rest of them you needed to answer. So were there any questions before I move on that you were like, I don't know how to answer that? Everyone was able to answer these with no problem? Okay. Very good then. All right, so if you guys would go past all these traits, these lovely, lovely traits that you passed on to your babies. And we were going to start today's with genetics notes day 5. All right, so we're going to be setting up a dihybrid cross Punnett square today. So before we walk through it slowly, I want to show you a video that's linked in your notes here. You can always watch it again if it helps. I would just point out it's a pretty long video. We're going to start at 6 minutes and 51 seconds. So if you watched it again, that's what I would do. You could watch the whole thing if you want. So we're going to let Mr. Anderson here explain to us how to set up a dihybrid cross. Oh, Mr. Anderson.
Whatever the day brings, Grammarly helps you communicate smarter, one message at a time.
How big would your Punnett square have to be? And so you're going to have to figure out what are all the possible gametes that.
Sorry, technical difficulties.
Start dihybrid crosses, and this is where the mistake really starts. And so if we look at this parent, this is a typical dihybrid cross. Let me tell you what the letters stand for. The R stands for round pea seeds, and the Y stands for yellow seeds. If it's the recessive, that stands for wrinkled, and if it's a little y, that stands for green. And so we're looking at a dihybrid, so that means 2 traits. We're looking at seed shape, round or wrinkled, and seed color, yellow or green. So now we have to do a dihybrid cross. And so the tendency, if we look at this parent, the tendency is to see that there are 4 letters over here, there's 4 boxes over here, and then you just simply write them out. Big R, big Y, little y, and then you get a weird answer and you don't know what to do with it, okay? That's wrong, that's a mistake, okay? Whenever you're figuring out the gametes, remember that you have to give one of each letter. In other words, each of the gametes is going to have one of each of the alleles. And so let me clear this mess out of the way. So what do? Let's say this parent right here. And I'm going to write it up here so it makes a little more sense. Big R, big Y, little y. What possibilities could they produce? So they're giving one of each letter, remember. Well, they could give the big R and the big Y. So big R, big Y. That'd be one possibility. They could also give the big R and the little y. So they could give the big R, little y. They could also give the little r, big Y, or the little r, little y. Since they're giving one of each color, there's only one of each letter, excuse me, there's only 4 possibilities that they can give. So it's getting to be kind of a mess, but those are the 4 right here. And so those 4 are going to go across the top. So we've got big R, big Y, big R, little y, little r, big Y, little r, little y. So those are the 4 gametes that you could produce. In other words, with this parent, you can only get 4 combinations of each of the 2 letters. Same thing down this side. So it's going to be same thing on written down this side because this other parent is going to be exactly the same. Okay, so it would take me a long time to write all of those out. So let me throw those in here. So these would be the parents, all the possible gametes you could get. And if I fill those in, these first 9, if you look at them, let me get a color. It's different. Let me grab a yellow color. And so this one right here is going to be round and it's going to be yellow. So it's going to be round and yellow. And this one you can see it's going to be round and yellow and round and yellow and round and yellow, round and yellow and round and yellow and round and yellow and round and yellow and round and yellow. In other words, 9 of them are going to be round and yellow in shape. And the only reason why is that the R is dominant, and so you could have one like this where they're hybrid for both and they're still going to be round and yellow. And so let me try to add the next ones. So what about these next ones? Well, the next ones are going to be round and green. So let me get a different color. So these ones are going to be round and green because the round is dominant, but they don't have the dominant for the yellow. So they're not going to be, let me get rid of that. Let's add the next ones. So these ones are going to be wrinkled and yellow. So again, I got to get a different pen. So these ones are going to be wrinkled and yellow. And then if we look at the last one, it's going to get all of the recessive alleles. And so that one's going to be green. It's going to be green and wrinkled. Okay, and so when we say there's a 9 to 3 to 3 to 1 ratio, that's just a typical dihybrid cross. We're going to have 9 of the phenotypes that are round and yellow, 3 of the phenotypes that are round and green, 3 of the phenotypes that are yellow and wrinkled, and then only 1 of the ones that's not. And that's only going to work if you are able to set up your gametes correctly on the side. Now it's super hard for you to answer a question like this on a test. You're rarely going to have to draw a dihybrid cross, but it's important that you understand the concept.
All right, I'm going to stop him there. Okay, so he went through that pretty quickly. What we're going to do now is we're going to walk through it very slowly. And so hopefully some of the things that you were seeing that Mr. Anderson was going through on the video make a little bit more sense. Okay, so to get started here, we're looking at dihybrid crosses. So di means 2. So we're looking at 2 traits instead of just 1. So before, when we were doing the 2x2 Punnett squares, those were just looking at 1 trait. So we only had 1 type of letter, and we put 1 letter on each square. Today, we're going to be changing things up, and we have 2 traits, so we have to use 2 letters for each gamete, and there'll be 2 letters on each part of our Punnett square. All right, so we're going to look at the same traits that Mr. Anderson just went through on that video, but instead of using R's, I'm going to use S's to represent smooth, the dominant trait, and little s is going to represent a wrinkled P. So we're looking at 2 traits of peas. So these would have been traits that Mendel would have looked at when he was working with his peas in his garden. And then we're also looking at color. So the color yellow is dominant over the color green. And I know you're probably like, Miss Klepper, every pea I've ever seen in my whole life has been green. I get it, me too. But back then, apparently yellow was dominant over green, and that's what Mendel saw. So we're going to keep with Mendel's findings as we move forward. All right, so if we cross 2 parents, so these are peas, but there are males and female plants as well. So if we cross 2 parents who are heterozygous for both traits, then we're going to be doing a cross that looks like this. So big S, big Y, little y is the genotype of one parent, and the other parent is the same. Okay, so this is our cross. These are our parents' genotypes. So remember that you get only one allele is given from each parent in the gamete. So when we're looking at dihybrids, we have to include one version of the S allele. This is a typo in your notes. It says R. I changed it to smooth to S. So if you guys would change it so you don't get confused later when you look at this. So they're going to get one version of the S and one version of the Y in every gamete. Okay, so here are our 2 parents. And one thing that I don't think Mr. Anderson did very well in his video was explain how to figure out the gametes. So we use what I like to use what looks very similar to the FOIL method in math. So FOIL stands for first, the F is the first set, O means the outer set, I is for the inner set, and L is for the last set. So if you have done this in math, it's very, very similar, okay? So because these are heterozygous for both, we can get a gamete that has a big S and a big Y. That's one option, okay? The big S could combine with the big Y. And that would be our first gamete here, and I'm gonna make this dad. So I'm gonna make him, this is his first sperm that's possible, is a big S, big Y. He can also make big S, little y. So that's going to be his second sperm. Because he's heterozygous, he also could have little s, big Y. That's an option. And he can also have little s, little y. Now, a parent can only pass on what it has to pass on. Okay, so there's 4 different gametes here because this parent is heterozygous for both traits. Sometimes there's going to be less than 4 different ones, but there will always be 4 gametes. All right, so the same thing goes with this. This is the female over here, right? So same thing, we can do this again. So the first set would be S, big Y. So that's her first egg. The outer set is big S, little y. I'm just referring to the FOIL method here. The inner set would be big S, I'm sorry, little s, big Y. And then little s, little y is the last set. All right, so just like before, when we did the 2x2 Punnett square, these are the gametes of the parents. So the first thing you need to do is be able to figure that out. What possible gametes can the parents pass on? Okay, that's step 1 of your I can statements today. So you're going to have to be able to do this for your homework, is figuring out what gametes the parents can pass on. Okay, that's step 1. Now, when you set up your Punnett square, this is a 4x4 Punnett square now because there's 4 possible gametes. So when you set it up, you're going to put the 4 gametes of one parent on the top, along the top here. And just remember, you need to have one of each letter. Okay, so our parents were big S, big Y, little y, but their gametes are going to have one of each letter. So you put the parents' gametes along the top. So this was done for you here. So this, let's say this was dad. I'm gonna put little sperm tails on here so you guys remember that these are gametes, right? And then you put the other parents on the side. So one parent along the top, the other parent on the side. So these were dad's sperm. And these were mom's eggs on the side, okay? So now you're gonna fill this in just like you did before, but there's a few rules now that you have to keep track of, okay? So the first one is always write the S alleles first, okay? They're first in the gametes, write them first in your child when you write the genotype. And then write your Y allele second, okay? And then always still put a dominant allele before a recessive allele if they're both present for the same letter, okay? So for instance, if you have a big S and a little s and a big Y and a little y, you would write the big S before the little s, just like before. But remember, your other rule that you're learning today is that the S's should stay together and the Y's should stay together. So let's fill this in. So just like before, when we were a 2x2 Punnett square, you're going to take the gamete from the top. Dad's sperm is going to meet mom's egg right here, and boom, they're going to make a baby. So the first baby they'd make is big S, big S, big Y, big Y. Write your S's first and your Y's second. The second possible baby here would be big S, big Y, little y. Moving to the right, we would have big S, little s, big Y, big Y. And then the last one would be big S, big Y, little y. The S's are a little bit hard to tell the difference between. I apologize for that, but you should be able to figure it out because they're, smaller. So why don't you spend some time right now filling in the rest of this yourself? So fill in the next row and complete this Punnett square. All right, so hopefully this isn't too challenging. And everybody was able to follow the rules of how to do this. So I'm probably not going to finish all these just because on the next page, the answers are given to you and they're written out nice and easy. So if you scroll down to this page, we have all of the offspring or all the genotypes written down. Now, once you have the Punnett square completely filled in, Okay, so that's the second step. First, figure out the gametes, set it up. Second is fill in the genotypes of all the babies. That's step 2. Now, step 3 is looking at the phenotypes. Remember, phenotype means what the pea looks like, its physical characteristics. So let's start out by looking for any of them that are going to be smooth and yellow. So if they have even one big S and one big Y, they're going to be smooth and yellow. So let's find all of our smooth yellow peas here. So again, we're looking for a big S, big Y. So this is going to be smooth and yellow at first square. Moving to the right is going to be smooth and yellow. This one is also smooth and yellow. And so is this last one, smooth and yellow. And the reason that whole first row is smooth and yellow is because look at this parent right here. They're big S, big Y. So every one of their offspring is going to have the dominant trait, right? Same thing goes with this gamete. It has a big S and a big Y. So everyone in this column is going to be smooth and yellow as well, right? And you can see that looking at the genotype. So are there any more smooth and yellows in here? As you look through, here's one big S and a big Y. And here's one right here, big S, big Y. So if we count these all up, what you're going to find is that there are going to be 9 smooth yellow peas, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 smooth yellow peas that are dominant for both traits. They're dominant smooth and they're dominant yellow. All right, so what I want you guys to do right now is use your scissors tool. So it used to be a scissors, now it looks like this squiggly line. Still, I call it the scissors tool. And you're going to scissor your peas that you just drew and copy them. And let's paste them on the Punnett square over here, so we don't have to redraw these. And over here, I want you to find all of the peas that are going to be smooth and green. So they're going to have at least one big S, but to be green, they have to be little y, right? So we're looking for a big S, little y. So here's one, big S, 2 little y's. Here's the second one. Those 2 are both wrinkled. So here's one, big S, little y's. So here is our third, smooth and green. All the rest of these have little s, so they're going to be wrinkled. So if we count them up, we have 1, 2, 3 that are smooth. So they're dominant for smooth, but they're recessive for green. All right, again, let's scissors, lasso, whatever that is up there. I think it's supposed to be a lasso. And copy our peas that we just drew. And let's move our picture down here. When you paste it, it's going to be too big. So you're going to have to minimize it with your double finger. And then drop it off so you don't have to draw all these peas again. The scissors / lasso tool is my very favorite. All right, so for this one, I want you to find any peas that are little s, meaning that they're wrinkled, right? Little s means wrinkled, but they have a big Y, so they're gonna still be yellow. And I'm gonna use orange to represent the yellow for this one. So little s means wrinkled, so I see one here that's wrinkled in yellow. little s was wrinkled in yellow because it still has that big Y. Here's one here. Let's just make these yellow so that you can tell that they're still yellow. So I see 3 wrinkled yellow P's. So they're wrinkled, which is the recessive trait for shape, and they're yellow, which is the dominant color. All right, let's lasso one more time. Copy, and let's paste these over here on this last. This one you shouldn't have to resize because it's the same size Punnett square. All right, and for this last one, I want you to find the one that is recessive for both traits. It's wrinkled and green. And if you lassoed your P's like I did, you should see that there's one box left. That's little s, little y, little y. So this one down here in the corner would be wrinkled and green. So there are 4 possible phenotypes, right? You can be smooth yellow, you can be smooth green, you can be wrinkled yellow, and you can be wrinkled green. So we have 4 possible phenotypes of these offspring. Okay, so now you are going to have to be able to figure out the phenotype ratios of the offspring. So let's write down the numbers that we came up with. So when we count up the numbers that are dominant for both color and shape, so they're smooth and yellow, we got 9 of those. When we count up the number that are smooth and green, so those were up here, we had 3. There were 3 that were smooth and green. And we count up the number that are wrinkled in yellow, we had 3 of those. Right, they're right here. And then the last number is the ones that are wrinkled in green, or recessive for both. And there was only the one little poor P down in the corner, all by himself, the odd man out. So this phenotype ratio would be written 9 to 3 to 3 to 1. Okay, so this would be the phenotype ratio of this cross. So you are going to have to, you're going to have to be able to figure out the phenotype ratio in your homework tonight. So the order is very important. So the first number is always going to be the number of dominant, meaning that they're dominant for both traits, right? So here, let me change this. So our 9 was the one that was dominant. Okay, so just like before, the dominant number always comes first. And in this phenotype ratio of the dihybrid cross, the one that's dominant for both traits goes first. The second number is the ones that are dominant for the S. So the first letter, so dominant for the S and recessive for the Y, so little y. Which was 3. The third one is the one that's recessive for S and dominant for Y. And the last number is always the one that's recessive for both. Just like before, recessive always goes last and dominant goes first. All right, so in our case up here, we had our first number was 9. That was our dominant dominant. The second number was 3. That was the dominant recessive. The third number was 3, and then the last number was 1. So you're going to have to do that in your homework. You just have to remember the order, and you can look back at your notes here to see that. All right, so here is one last problem, and I want you to go through this with me because this is what your homework's going to look like. So you have to remember the words heterozygous and homozygous. If you were like, I don't remember what that means, look back at your notes from day 2. Hetero means different, homo means the same. Okay, so we're going to now get away from P's and start looking at humans. So we're going to suppose that black hair, we're going to use a uppercase B, is dominant over blonde hair, lowercase b. And that brown eyes, big E, are dominant over blue eyes, little e. Okay, so we're going to cross a female who's heterozygous for black hair. By the way, this is a typo right here because if she's heterozygous for both, she would have brown eyes. So I would like you to change this. She's heterozygous for black hair and brown eyes, with a male who has blonde hair and he's homozygous for brown eyes. So I guess really step 1 is figuring out the genotypes of the parents. Okay, so what would mom's genotype be if she's heterozygous for black hair and brown eyes? What size letters would we use for her genotype? You can put it in the chat or anyone in class can say it out loud. What would mom's genotype be if she's heterozygous for both? Oh, you guys are making me nervous. Yes, she would be big B, little b, heterozygous for black hair, and big E, little e, heterozygous for brown eyes, right? So she has, when you're writing the genotypes for the parents, you must include 2 of each letters. Because remember, parents, yourself included, people have 2 of each letter. Okay, the gametes are the one that are only going to have 1 of each letter. All right, how about dad, who's blonde hair, has blonde hair, and he's homozygous for brown eyes? Yep, so he's got blonde hair, so he needs to have 2 little b's. And he's homozygous for brown eyes. Homozygous means 2 of the same. And brown, we're representing brown with big B. I'm sorry, big E. Sorry. So big E, big E. All right. So parents' genotypes are important because you can't figure out parents' gametes if you don't have their genotypes written first. Okay, so let's figure out what the possible gametes are for this female here. And I wrote the little symbol for female in front of it. So just like before with the FOIL method, we're going to go big B, big E is a possibility. And what can big B also go with? A little e. Okay, so that's the outer letters. And then the little b can also go with big E. And our little b can also go with little e. So because this mom is heterozygous for both traits, she has 4 different possible gametes. We call these her gamete combinations. What letters can she pass on to her offspring? All right, what about dad? What gametes can he pass on? So he can pass on a little b, big E. What else? Does he have a little e to give? He's not heterozygous. He's homozygous for both. So he can only pass on what he has. So what else could he pass on? I have a student shaking his head in my class, nothing. So even though he's homozygous, so he can only make big E, big B, big E, he's still gonna make 4 of them, okay? So that yes, they're all gonna be the same because he's homozygous. So all of his gametes are gonna be the same, but I still want you to write them out because when you fill in the Punnett square, you still need 4 gametes from dad. All right, so let's put our parents on this Punnett square. I'm gonna put dad on the side here. So I'm gonna put my dad's sperm on the side. And then I'm gonna put mom's gametes on the top. So just the ones that we wrote down up here, we're gonna move those to the top. And once that's done, now you're just gonna fill in the Punnett square like you have been doing. And remember to keep the B's first together and then the E's second for each of the babies. So you're bringing mom's egg and dad's sperm together and making the possible baby. Are they? Fill in the Punnett square and you will see if they'll always have, somebody just asked, their kids are always going to have brown eyes. This is why we got to fill in the Punnett square. We can answer questions like that once we have the Punnett square filled in, right? So once you've filled in this top row, because dad's gametes are all the same, the babies below the top row are all gonna be the same as the one above it, right? Because it's the same gamete. I still want you to write it all out. So no shortcuts, please, no arrows. I want you to write it out. If you want to use your lasso tool, you can, because it's, the best thing that Notability has to offer. But I do want you to write out every possible genotype in your Punnett squares for your homework. Oops. So Aiden, are all their kids going to be brown eyes? All right, so once you have your Punnett square filled in, oh, I made a mistake. Nobody caught my mistake. Maybe you did and you didn't say anything. It's easy to make mistakes if you're not paying attention. I just made one and I've been filling in Punnett squares for years. All right. So now once your Punnett square is filled in, now you can start answering questions about it. And I would like to first start off by saying, what is the phenotype ratio of this cross? So the first number in the phenotype ratio, remember, is the number that are dominant for both traits. So they're dominant for B and they're dominant for E. So how many would we write down for our first number? 8. Yep. So we have one here. So that means all of these are, right? And this whole column is also dominant for both. So our first number would be 8. All right, and our second number are how many are recessive for B, but dominant, dominant for E. Sorry, recessive for B. Let me write this correctly so that it's not confusing. And dominant for E. Wait a second, hold on. Let me back up. Sorry, I just screwed that up. So it should be dominant for B and recessive for E. That's your second number. Sorry about that. So we're looking for how many have a big, at least one big B and then their little e, little e. So how many of our babies have that? 0. Okay, there are no babies that show to be dominant B. In fact, all of our other babies, if you look, are going to be little b, little b. So then our third number is how many are recessive for B and dominant for E. So it's the opposite of the second number. Are there only 4 or are there more? Yep, so we have one here and we have one here. And remember, because dad had the same gametes, all of the babies below are going to be the same. So there are 8. And then our last number is always how many are recessive for both traits. So they have little b, and they're recessive for E. Little e, little e. So how many do we have of those? 0. We already have our 16 already in our ratio, right? So remember, this is a 16 square Punnett square that you're doing today. And so you should have 16 numbers in your ratio if you add them together. So it would be 8 to 0 to 8 to 0. All right. The next question is asking how many of the offspring would be totally heterozygous. So when you see the term totally, that means they're completely heterozygous. So in this case, it would be big B, big E, little e. So what percent of our offspring are going to be that? Oops. Yes. So somebody in my class is saying 25%. So how did you figure that out? Yeah, so there's 4 right here, right? These 4. So to do percentages, this is going back to, I don't know what grade math. You would take 4 divided by 16, because there's 16 squares. You can reduce that to 1/4. And if you divide 1 by 4 times 100, it's 25%. All right, what percent of the offspring are going to have blonde hair and blue eyes? 0%. So remember, blonde hair would mean the baby would have to be little b, and little e. And there are no babies that have that genotype. All right, that was a lot. So now it's your turn to practice doing this yourself for your homework. So on the next, there's 2 pages you have to complete, okay? And they're just like, the first one is just like the one we just did, okay? Black hair is dominant over blonde hair using the letter B's, and brown eyes are dominant over blue eyes. So you're crossing a totally recessive female. Okay, again, totally means she's completely recessive for both traits. with a male who's heterozygous for hair color and eye color. So the first thing you're going to do is figure out mom's genotype and phenotype and dad's genotype and phenotype. Then you got to figure out mom's gametes, dad's gametes, set up the Punnett square, fill it in, and then there's questions you have to answer down here. So I would like you to get started on that. We have until 11:30, so you guys have 33 minutes to get this done. And so please use this time wisely right now and ask questions. We can make some breakout rooms. Are they already made?
Yes, they are.
Awesome. So if you need any help, please ask and we can put you in a breakout room. Whoever's recording, can you stop recording? And if I might be pulling some kids into a breakout room if you need any extra help, or I might just check in with you. So 30 minutes you guys have. Let's get this started. I would say you could easily get it finished as well. I'm not sure who's recording, but if you guys want to, if you could stop the recording so we don't have an hour-and-a-half long video to put on Canvas.
Yep. He'll stop it shortly. Also, really quick, guys, I've got those breakout rooms set up, and I've set it up so where you can actually come into the breakout rooms if you choose to. If you have like a group of people that you want to work with, like you have some friends that you want to kind of bounce these ideas off of, go ahead and pick a breakout room you want to go into, and then go ahead and go in there. For those of you who are in person, I will be kind of bouncing around to help you guys out here as well. Okay.
Mr. Austin, can you stop the recording?